The next, I want to talk about some properties that integrals have, and specifically, I want to talk about. I want to talk about the following. Let's let f and g be functions that are integrable, meaning that the integral makes sense, and let's let a and b be constants. So a and b are constants, and f, g are integrable functions. Okay, over some path. Then it turns out that the integral of af plus bg is going to work exactly how you think it'll work. You can separate the plus in the function here. So it's going to be the integral of af plus the integral of bg, and then you can bring the constants out. So this is a times the integral of f plus b times the integral of g. Okay, so complex integration is linear in the sense of linear algebra, right? If you think of this as a linear operator, this is linear. The property that we just talked about before was, so this was at the end of the previous video, if you have f over, so if you're integrating some function f over some path or over some curve gamma, and then you orient gamma so that it's negative, in other words, take the opposite orientation, you can do that at the cost of having a negative in your integral. Okay, so the integral of f over some path gamma is going to be minus the integral where you orient it the other way. And then the third property that we can talk about for now is also an idea that we've seen before. If I have a union of two paths, so remember this means that you have some path gamma 1 and then another path gamma 2, and then gamma refers to this entire curve. So it's you can think of it as kind of a piecewise function. But the point here is that as long as gamma 2 starts where gamma 1 ends, then the integral of a function over gamma is going to be the integral of this function over gamma 1 plus the integral over gamma 2. The book, by the way, does not use this union notation. The book uses the notation that this is gamma 1 times gamma 2. But as long as you understand the notation, everything is fine. Yeah, I mean, as long as you understand the idea, the notation's not too important. Okay, so these are all properties that integrals are going to have for now.